Hi, I'm Shrishti Singh. My register number is UR14CS232. Today we are going to see the sixth experiment of a system software and compiler lab. Our sixth exercise is based on a single pass assembler for SIC. Now mainly in this exercise, we have to stimulate the concept of a single pass assembler for simplified instructional compiler. Now what is basically an assembler? An assembler is a program that accepts an input as an assembly language program and produces its machine language equivalent, that is our object code, along with the information for the loader. Along with the loader, it will give the output. Now if you are using an assembly language, it provides more control over handling particular hardware compiler. It generates smaller, more compact executable modules and offer it the result. It executes faster. Now my code. Over here the packages are being imported. A class is created over here. Now we have to open and read the input file. Now there are various input files. One second, I'll show you. Sorry. Now see, one input, this is my input file over here. This is my input which is being given to the compiler. Copy start, this is the starting address, load alpha, store it in beta, alpha equal to reverse word 1, beta reverse word 1 and end. This is my input which is being given. Now we will be using opt table, symbol table for the generation, and it will be stored over here. Now my code. Now in this input line we will see whether my if the input line has the opcode start, then we'll proceed with the following steps. Now over here my input is having start. Now if my input has start, we'll see whether any of the operand field is starting with our operand value. If it is starting with an LC, then we'll initialize it with a value, or if it is not having, if there is no value in the operand field, then my LC is set to 0. Now we'll write the input to the intermediate file over here. Now if my opcode, till my opcode reaches end, we have to do the following. If till my opcode reaches end, now if my opcode till my opcode reaches end, we'll check for the symbol table. If the symbol is not available from that symbol table which has been entered, then what we'll do, the memory, we'll check in the memory address in which it will be stored, and if it is not available, an error message will be displayed. Now if the opcode is present, if the opcode is present in the opcode, then my LC, that is my C dot length, will be equal to 3, and we'll start writing the location counter, opcode and operand field to the output file along with the object code. Now if my opcode is a word, now if it reaches end, we'll stop, and if my opcode will be a word, then what we will do, then again that is my location counter, it will be incremented by 3. If it is a byte, it will be incremented by 1. If it is a reversed word, it will be equivalent to the operand value of 3, and then if it is my reverse word, then the increment will be equal to the operand value. And if there is no symbol table in the operand field, then the operand address is assigned to 0 and it is assembled with the object code of the instruction. Then the processed line is written in the intermediate file along with the location counter. Now to find the complete length of the program, we need to subtract the starting address of the program from the location counter. Now after this, as you can see, I told you over here the same thing is happening for my location counter. It is for my symbol table opcode, then it will return a word. If it is a word, it will be incremented, the local counter will be incremented by 3. If it is a reverse, as you can see it over here, if it is a reverse word, the operand value will be equivalent to 3, and if it is a reversed byte, then the equivalent value will be the operand value itself. This is the, now once all the thing is loaded over here, again with the read and the input file will be opened. Now if the input file has the opcode start, now if my input file is again having the input as start, we will see it's given over here. Yeah, if it is having the start, then any operand field after start, it will be initialized to the location counter to the operand value, and if there is a no value, then my location counter will be addressed to as 0, Then the input will be given, the input will be written to the intermediate file. Now if the opcode is equal to end, we'll check the symbol table. If the symbol table is not available, then we'll enter that symbol into that symbol table along with the memory address in which it is stored. Otherwise the error message will be displayed. Then if there is an opcode present, the opcode will be present in the opcode tab. Then my counter will be incremented by 3, that is my location counter by 3, and the same way my word byte will be incremented. So at last what we'll do to find the complete length of the program, we'll subtract the location counter with the operand value that we have got. Now we'll run this program and we'll check. As you can see, for the input that we gave, we are getting the operand code for that object code for that particular input file that we gave over here. H copy 001. This is my starting address over here. That 1000 was my starting address that is being displayed. This is my text. This is my end. This is my header, text and end, which is being displayed of that object code. This is the 6th experiment of System Software and Compiler Lab. Thank you.